I want to tell you about one of my favorite numbers above 1 million, which is 2 to the 1024. So where do we get this number? Well, it comes from this piece of digital art, which I studied in college. It's called Every Icon by John F. Simon Jr., and it will eventually show every possible icon, every icon that's representable in black and white on a 32 by 32 pixel grid. And if you look at it, you can see it's doing this little animation wiggle thing here. Let me make it a little bigger so you can see it okay. And what it's doing is it's counting up in binary. And you can see it's made a lot of progress on the first row. It's gotten a good start on the second row. And it's been running since 1997. So at 9 p.m. So it starts to give you some sense of how big some of these numbers are that we're dealing with. So you might ask, well, how many different possible combinations are there? Well, you can think about it as it is a grid that is 32 by 32, and the first pixel can be either black or white, so that's 2 states. And then the next pixel can be either black or white, so that's for each of those first 2 states, there's 2 more states. And then another black or white, so that's another 2. And we keep doing that, and that's going to be how many states there are. And there are 32 times 32 squares, so 32 times 32, which is 1024. And so that means that there are going to be 1024 twos multiplied all together to get the total number of states. So we can write that as 2 raised to the power of 1024. That's a really big number. We can try to get an idea of how big that is. So I put it into Wolfram Alpha and asked it to give it to me in base 10. And it comes out to this number here, which is quite big. It's roughly 1.8 times 10 to the 308th power. So that's basically almost 2 with 308 zeros after it. To put it another way, that's a Google cubed times another 10 to the 8th just for fun. It's really quite large. A professor I had, Craig Dietrich, phrased it nicely. He saw this art piece and said, oh, well, to conceptualize how big this number is, if you took a 32 by 32 black and white camera and you sort of teleported it to every point of space in the universe, and then you turned it to face every direction at each of those points, and you did this backwards and forwards in time for every point in time, you would probably get a subset of all the icons that this will eventually display, which I thought kind of put it in a nice perspective. And so I thought it would be fun to build an app that would kind of let you play with it a little more. This one just sits here counting, but you can also get an idea of how big the number is by playing with it a little more interactively. So I have a little sort of prototype iPad app that I built here. The code will be in the description, a link to the code on GitHub. And we have our grid here, and I can click the squares on and off. And as I click them, you'll see a number at the bottom, and that number corresponds to the number that the grid represents. So you'll see if I click the 1 here, then that corresponds to the number 1. And then if I click on the second one, that's a 2, 4, 8, and this is counting in binary. So if I have an 8 and then I click on this one, then that's a 9. This one will add 2 to that, so that would be 11. And so we can do, basic binary counting, turning those on and off. And if I, click one over here, that's the 4,194,304th place. So you can check these off and on and see what the values come out to. And something I noticed as I was playing with this was, so there's a slider down at the bottom, and the slider lets you crank through all the values from 0, where they're all empty, to if you fill them all in, you would have a number where it's a 1 in every place of a 1024 digit binary number, and that would look like this. So I'll take this and drag it to the right, and if we get all the way to the end, you'll see that it's full black, and there's that 1.8 times 10 to the 308 that we saw before. So that's the biggest number that this can represent. I think maybe it's technically that -1 because all the digits are filled in and then one more digit you would roll over or something along those lines. It's really big. And here's something I noticed. So let me crank this back to the beginning. And you'll notice that if I draw here, the number is changing. Each of these is representing a different unique picture, but the slider doesn't look like it's moving. And if I click down here on the bottom row, even up here the slider's not moving. It takes until I get to, let's see, about 8 from the end that we just start to see the slider moving, and then it starts to take off. And even up to here, 3 from the end, it's only moved, I don't know, about 1/8 of the way across. And when you think about this, what this means is all of the images here, let's go back down to where it's just started to move. All of the pictures that we can make with all the possible combinations of all these turned on and off, except these last 8 at the bottom, if we stick those like that, all of those pictures all occupy this tiny blue sliver and the edge of the scroll bar here. And then if I change one of these, then we get a whole new section of new images that have not been produced in the spot to the left. And each tiny little slice of that scrubber is a whole new set of unique images. Oh, and I've also got plus and minus buttons here, so you can increment and decrement the number and see what that would look like. So there, I decremented here this digit underflowed to now show all of these filled in, and now we start counting those digits down, which is also kind of fun. So it's a kind of fun way to play with binary. So I can reset this to 0, which is blank, and then draw a picture. And I can draw any picture I want here, as long as it works in black and white. Of course, this would also work in color, and it's kind of fun to think about, any JPEG or PNG, or I'm not going to pronounce that other one. You know the one I'm talking about. You say it correctly. Every one of those pictures is just a grid of numbers that represent a brightness value. Matt Parker has talked about this in his stand-up comedy routine about spreadsheets. And it's kind of fun to think, like, this number down here at the bottom, that is a unique number that uniquely identifies this one image. And if I fill in this pixel down here, that is now a different number that uniquely identifies this other image. And any number you could come up with uniquely identifies one image. And in some sense, all the possible images already exist, in the sense that, those numbers are there. We know between 0 and this big number, all the numbers are in there. And it's just a matter of finding which ones represent images that are, something we care about, and which ones are just seemingly random noise. And I thought that was a fun way to kind of play around with the idea of how big this unfathomably big number is.